Well, kia ora, and welcome to Nigel Banks from Octopus Energy, speaking to us from the UK. Nigel, lovely to have you on the show.
Great to be here. Thank you for inviting me.
I'm curious about Octopus Energy and the things it's doing with new homes to try to reduce power bills. But first, I think it's worth sort of trying to understand from a New Zealand consumer point of view what Octopus Energy is and does in the UK, because most New Zealanders won't have heard of Octopus Energy. And so could you give us a sort of a backgrounder on, Octopus, how big, how old, what it does?
Yeah, so Octopus Energy was founded about 9 years ago by Greg Jackson, and as a technology company looking to deliver better, faster, better and cleaner energy to customers that is cheaper and deliver on the green revolution faster for both the people and our customers and for the planet. So it was founded 9 years ago, and in the last 9 years in the UK, we've grown from being from a startup to now being the UK's number one electricity supplier by volume, and having fantastic customer service and winning awards for that customer service. And that's very much been around the technology we use both to serve our customers, but also using technologies to provide innovative tariffs and services to our customers. So an example of that is we're one of the first suppliers to develop solutions where customers can use energy for free when there's excess energy available on the grid. So rather than turning off wind farms or solar farms, we allow customers to use that energy for free, which saves them money, but also reduces the load, makes use of that energy on the grid and reduces the payments that go to turn those wind turbines off. So those things called saving sessions, and that's now been rolled out across UK market. And that business, that model is now being rolled out across multiple countries. So we're operational as an energy retailer in 8 countries. And we also own and invest in generation assets. So we've got generation assets in another, I think, 17 countries around the world. So it's now quite a large company with over 10,000 employees. I think last year the revenues were nearly £9 billion. So it's going from a very small startup 9 years ago to now being one of the biggest energy companies. And the technology platform that Octopus set up was called Kraken. And that's now used by a number of companies around the world, including other competitors in the UK, and is available effectively as a license to allow other companies to use that same technology to offer their customers the same fantastic service, as well as the innovative products that help the grid, help decarbonise the economy, and also give customers fantastic service and deals.
Kraken, great name. Could you tell us, what it does and how it works?
So the Kraken software engine effectively manages the enormous amounts of data that you need to operate as an energy company, all in one place in a very simple user platform for the people working for the energy company. So if you ring us up, the energy specialist who you speak to will be able to access all of your meter data, all of your information about your payments, if you've got any smart and controlled tariffs, the technology that's connected to, all of that's in one place, and that energy specialist can deal with all those issues in one place. Legacy energy companies have typically got multiple systems. I mean, one company that's transitioned to Kraken, I think it had 200 different systems and lots of different departments that dealt with different queries. So that means you get passed from pillar to post and you don't get a very good service. It also means it was designed and set up around the modern, decentralized, intermittent renewable energy grid that is coming and enables us to look at the forecast for the weather, look at the forecast for the energy price, look at how many cars are expected to be plugged in that night, and work out what's the optimal time to charge those cars, what's the optimal time to charge those batteries, to both deliver the best outcomes for the grid, but also the best outcomes for the consumer. Because most people often get a flat, fixed rate of electricity when they're buying electricity around the world in almost all markets. But actually, almost all markets operate on in the UK, it's a 30-minute market. In other countries, it's shorter, 15 or 5 minutes. And actually, the cost of energy is wildly different through the day. And if you can make use of that energy when it's cheap, clean, green, and use that to fill up your hot water cylinder, fill up your car, charge your battery, then that makes it a lot cheaper for you to run. And if you can avoid using energy at peak time, that's often when the gas or coal peaker plant's turning on, You can avoid using that dirty, expensive energy and bring everyone's bills down, but certainly bring your own bills down. So the technology controls that equipment, gathers that information, and helps optimize the end consumer's proposition and their bills, but also helps the overall grid make better use of intermittent renewable energy and the devices that are in the home and spread around the grid much better.
So can you give us an idea of what it's optimizing for? Because most companies try to sell the most of their product at the highest price, which from an electricity point of view is, that's not great for a consumer. It's great for the company. And to be frank, that's how New Zealand power consumers have seen electricity as something which is charged at the highest possible price to them, and their role is to try to reduce their power consumption to reduce their bill, because the power companies are going to do it for them. So could you tell us, what are you optimizing for? What is the Kraken algorithms, if you like? What are they optimizing for?
So they're optimizing for the best outcome for the consumer, and that's often and usually correlates for the best outcome from an environmental perspective, and usually the best outcome for the grid, especially if it's locally managed and locally operated grid. So the New Zealand market has got locational pricing, so each part of the grid has different pricing. And so in that context, we are optimizing for the local grid requirements around the consumer's best interests. So what is the lowest price we can achieve for that consumer, and what are the services we can provide to the grid with that equipment? And so flipping that on its head means you can create some really fantastic propositions for consumers and do that in a way actually that can still make you the same margin, even better margin. One of the most innovative tariffs, and the tariff that I lead on in the UK and globally, is a zero energy bill tariff, where we don't charge customers anything for their energy. And that tariff, we can actually make the same margin or slightly better margins than we would do in selling customers energy. So that you think, how on earth does that work? That works because if the home is generating energy and we can store the energy in a battery and put it back into the grid at peak time, we can make revenues from exporting that power on behalf of the customer in the best way possible. And we can also use that battery to help balance the grid and keep it in frequency and get paid for that. And we can actually generate enough revenues from exporting power and grid services to cover all the costs of the imported energy, often in the colder months, the darker months, and our operational costs to serve the customer, and guarantee no energy bills for that customer. So that completely flips on their head and shows the sort of potential that's there with this sort of offering. And we now guarantee, and we've got the first home built in Auckland, in New Zealand, with classic builders, where we're offering guaranteed no energy bills for 5 years for people living in those homes. There are some caveats. There's a allowance on electricity use, so it's not limitless free energy, but up to typical consumption a little bit more, you don't get paid anything. There's no standing charge. It's free energy. Beyond that point, you then pay for your energy above that.
And obviously that's for the energy itself, not necessarily for the lines component of the bill.
My understanding, that's covering the full energy bill for that customer is a zero energy bill. So we're covering all the cost stack of imports and standing charges by generating enough revenues to cover that off. So that is quite a transformation. We've got that live now in the UK. We've had it running for 18 months. We went live in Germany this summer, and so we've just gone live in New Zealand this week. That's a fantastic example of how we can optimize that. We did the same with electric vehicle charging, so we can deliver some of the best overnight charging tariffs by smart controlling when we charge your car. So you plug your car in when you get home from work, but it doesn't turn on straight away, because actually that's the worst time for the grid. When you get home from work, that's when the grid's at its most under most strain. If you tell us when you want the car charged by, I want it charged by 5 a.m, 100%. We will then work out how much charge the car needs to get and when's the best time to do that charging, set that schedule, let you know in your app the schedule is when it's going to charge, and we control that charging, and you'll have that car charged in the morning. And that way it's working for the grid, and it's delivering a better unit rate for that charging for the consumer.
Now, you've probably seen that just in the last couple of weeks in New Zealand, we've had the collapse of Solar Zero, which was a firm which offered a deal where you had a fixed price for electricity, and they would buy the panels and batteries and put it on your roof, and they essentially took on the cost of the capital of putting in batteries and panels, and it's the capital cost that's always the big hurdle for any homeowner consumer. How do you solve that capital cost problem? Because yes, batteries and panels are much cheaper, but it still costs something, and often it's not insignificant.
And that's one of the things that we've been looking at the supply chain of what we've been implementing in the UK and looking at the comparable costs in New Zealand. And to start with, they seem quite different. So we've been working to see how we can help with that. I think there's a few things to say. One is, if you're building a new home, that's the ideal time to put that equipment in from day one. You plan it in, you've got people on the roof doing the roofing, they can put the solar panels on at the same time. People do electricians are there doing the wiring. You can get the electrical wiring and the batteries put in at the same time. So if you can build it into the design from day one, that's a much more cost-effective way of achieving it. But also, the costs have come down significantly from where they were. I mean, from 10 years ago today, the panels are a tenth of the price and batteries are a tenth of the price. A tenth. Yeah, tenfold difference in price. In the last year alone, solar panels have more than halved in price from where they were. And so, actually, the equipment cost, the actual panels and the batteries themselves, typically aren't now the majority of the cost. The majority of the cost is now the installation, the labour, the accreditation, the permitting, paperwork that goes with that. So streamlining those processes is one of the key things that enables that. And obviously, in a new home, you can do that in a much more effective and cost-effective way. And I think the other thing to say is the ability now to bring in some of this equipment directly. Most of it is manufactured in China, as is most of that equipment. But they have, I think the staggering figure that we worked out last week is something like 4 million solar panels are made every day, or even maybe it's even every hour. It was a staggering amount of panels made now, and as a result of that, the cost has really come down to a staggering level. So there is an upfront cost. We don't get involved in support that, other than saying this is our supply chain rates that we buy at around the world and making that available to people. But it's for the house builder to buy that equipment themselves and procure that themselves, or if you're doing a retrofit, for the installers to install that equipment at the customer's cost, and then we guarantee the zero bill. One of the key areas we're working on in the UK, and also in New Zealand, is how do we finance that? So if you're buying a new home, if you've got no energy bills, typically your energy bill is your second biggest outgoing after your mortgage. When you do your mortgage calculation to work out how much money you can borrow, if you've got guaranteed zero energy bills, you could put that money towards your mortgage payments and be able to borrow the extra capital. And typically when we've looked at it in the UK, and I think it'll be similar results in New Zealand, is the savings you make on your energy bill more than recover the upfront costs and a mortgage level of interest payment and the ongoing maintenance requirements. Typically a battery has the solar inverter has a 12-year warranty, so it's expected to last 12 to 15 years now. Again, that's got better. The batteries have got cheaper, but also the quality's improved and the warranties that go with them have improved. So now the economics actually of installing some of this equipment is some of the best investments you can make from a financial return perspective, if you can get that initial cost to a sensible level. And that has been the problem. So five years ago, a lot of this didn't make financial sense. Now, with the cost of that equipment coming down, if you can get that delivered cost effectively to your home, then the finances really do make sense.
So in the UK, for example, the key component, you're right, is the finance cost. With the current costs of the equipment, where's the sort of break-even threshold, if you like, in terms of the interest rate? Is it 10%, 9%, 4%? Where are we at now?
So it does depend a little bit on the length of time you're borrowing that money over, obviously. So typically we're seeing people in new build homes buying them, part of that as part of the 25-year mortgage they would take out, currently at 4 or 5% interest rates. And on that basis, the typical upfront cost uplift on a relatively small 2-3 bed home is between £10,000 and £15,000 uplift in capital cost. And people in the UK are typically saving between £1,500 and £2,000 a year. So over a 25-year period, without including inflation, would be sort of £30,000 to £50,000 worth of bill savings for about £15,000 upfront cost. So that does recover its costs and the maintenance costs at around that sort of 3-4% mark. sorry, 4 or 5% mark probably. But the other thing to say is when you then went to sell that house should also be worth more because it's got that equipment in. So the solar panels should last 25, 30 years or longer. The battery should last 12 to 15 years. So actually those assets should still be operational and functional well beyond the time frame when you're looking to sell the home and retain some of that extra value as well. So yes, there is an upfront cost, but then there's fantastic savings that are guaranteed. But also then when you went to resell your home, you'll then be able to sell it on again. The other key market is in rented, both in socially rented and in private rented housing. And the model there is really quite attractive for landlords if they can slightly raise their rent level. So typically in the UK, we're talking increasing the rent by £30 to £50 to save people a month, to save people £150 to £200 a month from their bill. And that recovers the capital cost for the landlord and enables them to offer a bills included home with energy bills included. And that's really attractive. That's one of the main things that a lot of renters are looking for. A lot of people moving out of student accommodation where bills are included in their rental. And now they're getting into a private rented for the first time. And that bills included simplifies things. And it's a very low risk way because we're taking the risk on energy consumption and they're getting the rental yield for them as part of their initial rental income.
And just to be clear, the deal here is the batteries and the panels in the home are owned by the homeowner, and that when the house is built, the builder will come to Octopus and get a deal, I suppose, on the equipment and buy the equipment, and it's charged as part of the price for the house. But ultimately, the equipment on the house, the panel and the battery, is owned by the homeowner. It's not owned by Octopus. That's right?
That's correct.
Yeah.
We're providing an energy tariff and the smart control. The ownership of the equipment stays with the householder, and we agree the specification dependent on location, how sunny it is, and we agree the number of solar panels and the size of battery that's required for the typical size of home. So typically in New Zealand, home with about 8,000 kilowatt hours of consumption, it's about 8 to 10 kilowatt solar system, which is 15, 16 to maybe 20, 25 panels and a home battery.
So this offers the potential for a type of perpetual energy machine, that somehow you could actually roll these things out on every house, although obviously installation on existing homes is probably going to be more expensive and difficult than doing it on the job when you're building the house. But what are the barriers to just really going for it and doing it on every single house? If the economics stand up, and as long as the installation costs on retrofitting, if you like, aren't too high.
So your point about sort of perpetual energy machine, we have one in the sky that's there every day, sun, and we've got this now fantastically cost-effective way of converting that light energy into electricity and storing it in a very cost-effective way. So actually, it's one of the most cost-effective interventions to lower bills and address poverty or fuel poverty in a home now is solar and battery. Yes, there's other things you can do, improve the insulation, glazing, etc. But they are also quite expensive and require quite a lot of skill to do well. So actually, it can be a very one of the most financially attractive propositions in terms of bang for your buck, in terms of saving you can make for the upfront investment. But there is an upfront investment in that. One of the other interesting things is a lot of that upfront investment is going to be required by most countries investing in solar panels and in battery storage and in wind farms. But one of the questions is actually why shouldn't that be on the roofs of homes rather than in the fields? And why shouldn't those batteries be located on the outside of someone's home or in their garage rather than in massive battery parks in a field somewhere? That way the people who perhaps most need that energy support and energy security can have that locally and make those savings. So yes, there is, and people sort of say there's embodied energy and carbon that goes into making these batteries, making these solar panels. But typically that money that carbon is recouped within the first year or two of its operation, and therefore after that point it's saving a carbon, saving energy, particularly where it's offsetting higher carbon generation like gas or coal-fired power, which I know the majority of the grid in New Zealand is hydro, but you still have those peaker plants that are coming on to support the grid. So it's one of the best interventions in existing homes. The challenge, I think, in New Zealand is partly how do you do that and scale that up so it's cost effectively delivered. And that's around getting good supply chains and getting going. But the new build housing market is a fantastic route to market for that, because you've already got all the people you need on site there with those houses. You've got electricians, you've got the roofers, and they should be there to do it. So in our view, this is the standard that all new homes around the world could or should be being built to, and it's economically viable now. 5 years ago probably wasn't, but in a year or two's time it's going to get better as the costs continue to fall, particularly on batteries. We expect the cost of batteries to drop significantly further over the next year or two. Solar's come down such a huge amount, but batteries, home batteries, you look at the cost of the batteries compared to the cost of the batteries in a car, there's still a bit of headroom there, and still technology improvements that are coming down the road on batteries. So it really is quite exciting around the potential that has to make massive impacts in households across the world really now.
Nigel, thank you so much for spending the time late at night in the UK to talk to us about this. Nigel Banks from Octopus Energy. Ka kite anō, ngā mihi nui. Thank you very much.
Thank you.